Okay, we are back to this. So what we did here is missing one case somehow. Missing the parentheses, right? So let's see if we can generate them from the ground up, right? So this is wrong attempt. Only this possibility, right? At any step, either this or that, right? So we would expand the with this and expand the with that, right? But there is also a number of parentheses and it has to fully form, right? So that means limit the parents and a stack to check fully formed, right? So we want to do, right? So this is one, starting with 1, 0, open and close. Open, and we don't need to. And the basic is expand at every step. We will expand O plus 1, close the same, expand B, the base case is if open equal close equal to n, right? That means we append B, right? And return. Right, so now making sure we only generate valid parentheses, right? So if the number of open if the number open is less than n, then we can do this. Then after that number closest to this, then we do that. Is that correct? Let's see. Plus. So, okay, so seems like this case is wrong, right? So we want to be able to say that we want to be able to maintain the open parentheses stack, right? Stack. So because we have that, right? Right. So because we're gonna do this, oh, stack it at the end. Stack plus, right? So because this is matching, right? Stack plus is matching, right? So it's beginning to the -1 plus, right? Because if we close, we match the latest. Let's just call this open parenthesis OP, because if it close, right, that means we can match the last one, right? We expand close when it must match the parent. Match the open parent stack, right? So in this case, right, this is matched up until this, right here, right? These two match, these two match. So we're gonna add one here, right? So, and the stack has to be empty, right? And so when we get to here, right, that means everything good, stack is empty. So now, and not stack, right? So it match up until here, and then we go in here, we match, right? So what is this? Someone bring me something. just reply to some people. So we can only expand if not stack, right? If stack, right, then we can expand and stack, right? Right, if it's not stack, then we shouldn't expand, right? What's string? Oh, stack is at the end. OP is not defined. Oh, okay. Here we go. Well, let's see if it passed. Yeah. Nice. Well, I forgot to take a look at my mission. And this is probably a quest. Alright, well, we'll do this tomorrow. But now let's do some read and react and then substack. But let me get some water. Hold on, let me check. We get some water. Make good progress. Well, I finished the water. Alright, let me finish this. Oh, we already finished this, so let's move over here. We'll do the instant third maybe tomorrow. And for now, let's look at some article and then we write the substack with all these stuff. I don't even know. I was so behind on the substack post. So let's do that. unlock after completing all level. Good. So let's look at Reddit programming. Hacker news. OCD for a little bit. Let me move stuff. What? Okay. Can you? What? Tony Howard has died. Wow. Benny. How do you pronounce his name? The guy with the norm pointer issue, right? Oh, Howard. Horror? That's crazy. Invented quick sword. Rip Tony. What is this? Some spam, bro. What is this? Let's search this. Crazy number of spam these days. Okay. Tony. What's the cost of that? Hello. Mustafa Naim. How's it going? Good. Right now I'm just reading some stuff. I just finished some lead code portion. So reading some article and then and writing my Substack. Yeah, this solved some problem earlier. I'm taking a break. Are you bought? No suggestion, Polito. Just keep doing it. Right now, I'm doing this one. I finished the second one. I have this which I'm doing tomorrow. I think you just need to study, and I think look at NEET code or something. 150. Just do this. Look at the pattern. Each pattern. Do that. I think you just need to figure out the pattern and apply them. But I don't know. I don't. Just keep doing it, I guess. I don't have any advice. Sorry. I don't think anybody will be good. You just need to study and do it, right? I don't know. How is this story not showing up in programming? Tony, right? Tony. Yeah, nobody report here. We'll have to look at this. Stock market is bad today. Hold on, let me check some stock. E- Hmm. Okay, so let's go back to our Substack draft and put all this information in there first. Draft, yeah. So we did this. So we're gonna put this into here. Okay. Okay. This is one. This is two already. Oh wait, we did not read this, right? I think. So let's put them first. I note down some point here. So let's look at this again. Because I forgot. This is the problem of not writing the draft down when it was ready. Hmm. Okay. What is this one saying? Okay, so basically leave std c++ allocate emergency pool for exception handling. Should we watch this or no? We'll watch it maybe. Let's see if we can watch this. We'll watch this later after we finish the stuff here. To do. the Encore model in a tier 1. Known fixes automated to partial known AI recommendation plus human validation. Unknown. Medicine and aviation study encourages less reliance on AI. Okay, there's also some pictures. Interesting reply from the author in the Reddit discussion. Oh wait, still play music. I know, fine. Okay. A legend. No. Um, it's also known to say that no pointer is $1 billion thing. No pointer million. Let's read that, I guess. There's also Quicksort, right? Okay. Liquor Quicksort. What is this? Have we already solved this? But um, when did he say the? I don't care. Don't talk about stuff unless you interview him. Oh, he has. He has. Let's see if we can watch it. New reference. $1 billion mistake. No references. What was this? Okay, hold on. No references. References. $1 billion mistakes. All right, and can we link to that? Here we go. And can we get the link from here? See if we can capture the link. Okay, video. Oh yeah, nice. Okay, this one doesn't do that. Okay, so let's watch that. How do we see the? We open up a browser. Wait, hold on. How do we play the videos with the people here too? Let's just. How do we? How do we show the browser here on OBS to show the link, because it doesn't let OBS play it to the browser here. Okay, OBS, how to capture browser with sound. Okay, so the next question here is, can we do this? Find a YouTube link for this. Yes, we can. Muhahaha. Okay. So what we do is we do the
Well,
YouTube.
thank you all very much. Thank you.
Okay, hold on.
Very nice to see so many of you here again. It wasn't me that decided to give 2 talks at this.
Hold on. Let me bring up the YouTube site. Let's see. Browser. What? How do we zoom stuff in here? One second. Let's see. Come on, YouTube. All right. All right. So maybe we can put the slide here. There we go.
Well, thank you all very much. Thank you. Very nice to see so many of you here again. It wasn't me that decided to give 2 talks at this wonderful conference. It was the organizers, or actually perhaps it was a mistake. Perhaps it was a historically bad idea that I should do so. I thought I was going to just participate in a panel in which all the panelists would confess to having made historically bad mistakes. But I thought perhaps I would start by finding out whether there's any agreement or disagreement with the overall thesis that null references have been a historically bad idea. How many people here would agree with the statement that null references have been a historically bad idea? Great. And how many people would vote against that motion? Oh, I see. Well, I can see that the panel discussion will be a little bit one-sided. So, would either of you be prepared to come up here later on in the afternoon and present your view that null references were a good idea? Or at least not too bad? Will you do it? Thank you very much. Would anybody care to be a representative for the people who thought they were a bad idea? You said you would. Great. Well, I hope I will my stream of words will dry up sometime in the near future, and I'll call on you to make good my deficiencies. How about another vote? If I am really responsible for null references, and if I am, then it goes back to somewhere around 1964. In all that time, 40 years or so, how much do you think that null reference violations have cost in terms of programmer time, user discomfort, and general damage? Do you think it was less than or more than $1 billion? $1 billion in 40 years? Well, how many people would vote for more than $1 billion? American billion, I think, yes. More, please. More people for more. No? Right, good, a good half. And who think it would have cost less than that amount? And most people are agree with me that they don't know. However, we just say of the order of $1 billion, probably more than 1/10 of a billion, probably less than 10 billion. So while my two substitute speakers are thinking what they're going to say, I'm going to, I hope, entertain you with a little bit of history of how I came to make this a rather bad idea. My first job I took on as a programmer in 1960 with a small British computer manufacturer called Elliott's. And after I'd been there about 9 months, I'd learned enough about programming so that they asked me to design a new programming language for them. And very fortunately, I happened to find in the library, people used to have libraries in those days, a little grey-bound document of 23 pages, typescript, mimeographed, called Report on the International Algorithmic Language, ALGOL 60, edited by Peter Nauer.
ALGOL 60.
And I read that and was quite attracted by it, and took all the ideas for my new language from that document, but I left out all the complicated things like ifs and thens, which I thought that our customers would never understand. But fortunately, again, a little later, I came to understand them myself and suggested to my company that we should implement that language rather than a language I'd invented myself. Well, at that time, most people were programming still in machine code, and indeed all our manufacturer's software was written in machine code, including the ALGOL compiler. And the great thing about machine codes in those days is that you could understand them, and if you made a mistake, you could follow through and find out what the results of your mistake have been, and so diagnose what the mistake was. But if you were using a high-level language, that capacity was taken away from you, because you no longer regarded the store as consisting of 4,096 locations, each of which, of course, were, well, 4 and 7/8 bytes long in the case of Elliott's, or in the case of other manufacturers, of course, like IBM, they couldn't afford 39 bits in each word, so they only had 36 bits. But we wanted to protect our customer from knowing the details of the machine architecture. So I took it as a general principle that if anything went wrong with the code that you'd written, if you made a mistake in your program, the results of your mistake would be predictable by looking at the high-level text of your program alone. And you never had to delve into what they used to call hexadecimal core dumps in order to find out what had gone wrong and try and find out what caused it. And that was a principle of the design of the implementation. It had one quite expensive consequence, that whenever the program contained a reference to an array with a subscript, the implementation had to insert a check that the subscript was within the subscript bounds. In Algol 60, the subscript bounds were declarable by the program, both the lower bound and the upper bound. So for every subscript, there was two checks made that it was within its bounds, and indeed in a two-dimensional array or a three-dimensional array, there would be a separate check made for each subscript. And this really added quite a lot to the size of the code and to the time it took. On the machine that I started programming on, we could manage just about, well, it was less than 2 kilo operations per second, 500 microseconds per operation, and a test was 2 operations, of course. And it added 2 or 3 instructions to the length of the code, which was quite critical when you only have 4,000 words of 4 and a bit bytes each. But our customers accepted this, and they didn't know any better because they weren't given any option not to accept it. And as a result, they never had an undetected subscript error. Was that a historically good idea? Well, I think so. Yes. In fact, the world has discovered and is rapidly moving to a language in which the same policy was undertaken, and every subscript is checked against the array bounds on every access. The language Java has, after a gap of over 30 years, has reproduced the decision that I took in 1960. Well, I became very interested in a project for extension of Algol 60. I joined a committee whose task it was to design a successor to Algol 60, and I very much enjoyed making suggestions, contributions, as I called it, to the design of the successor to Algol 60. And one of the suggestions that I made, I called record handling, and essentially it brought the concept of an object into the language, an object to which reference could be made through a pointer. Now, of course, I knew from long and bitter experience with machine code that when you were using pointers and indirect addressing, you could wreak the ultimate havoc on the program that you were trying to write or test or run. Because if you happen to use a floating point number, or indeed an integer, as a pointer, and update the contents of whatever location it was pointing to, as likely as not you would update a piece of your own code. And now the effects of updating your own code are obviously that that the program subsequently, perhaps not immediately, perhaps much later, starts behaving in an entirely unpredictable fashion. in order to predict what is going to happen when you assign a floating point number to a location which is holding an instruction, you certainly have to know the instruction code of the computer, which I believed it was the purpose of the high-level programming language implementation, to prevent you from ever having to know that. Well, so I took it for granted that for every variable or attribute that could take a reference as its value, the programmer must declare the type of the location of store which that pointer was going to point to. So this is absolutely standard practice in modern languages, even C. Sorry, am I right there? C++ anyway. Require you, when you're going to use a reference, to say what kind of thing it points to. Usually a record or object consisting of several variables held consecutively in the store, and you were required to declare the types of all those variables, particularly, of course, if the object itself contained a pointer variable. It was very important to know that it was safe to follow those pointers and treat what they pointed to indirectly as being of the appropriate type, floating point, integer, or pointer. And these additional type information I knew perfectly well, and everybody now knows, can be checked at compile time. In the same way as the types of all the other variables and attributes which were not pointers. It was only actually after many years later that I discovered that that was, in fact, quite an original idea. I'd taken a lot of the ideas for record handling, object orientation from the Simula language, and more ideas from Doug Ross's programming paradigm or design pattern, which he called Plex. But neither of those at that time had any method of checking the types of the attributes or variables that were accessed indirectly through the pointers. Now, the great thing about record handling, I realized, was that if you structured your data as a set of records, you would never have a subscript error. There is no need to test whether the pointer is within range. You cannot construct a pointer that doesn't point to something that exists and is of the expected type. And that's logically impossible, and so here is a whole class of errors that can never happen again. Now, it really was quite a good idea to do this checking at compile time, because there was definitely a time penalty in doing all the subscript checking that my Algol compiler used to do for our customers. There was a problem with the subscript checking. A little later on, we asked our customers whether they would like the option of switching off the type checking after they tested the programs, because a lot of people thought this was a perfectly reasonable thing to do. I once said that removing type checking from your running programs and using them only for testing is like wearing a life jacket on your practice emergency drills and taking them off as soon as you really had, as soon as your ship was really sinking. But when we asked our customers whether they would like the option of taking the life jacket off, they said no. And we never put in a facility an option for switching off the type checking. But still, it was a very serious mistake for my company for a very interesting reason. Because a lot of the people who weren't our customers, but which we wanted to sell our computers to, were users of the Fortran language rather than the Algol language for which we had a compiler. We didn't have we were a very small computer manufacturer. We didn't have a great deal of programming effort, so we thought that we would provide a Fortran compiler by translating from Fortran to Algol. It's actually rather more difficult than it seems, but it took about a man-year. A good programmer produced something which could at least run Fortran programs, but not all of them, but many of them, by translating them into Algol. It was a disaster. No Fortran user would touch it. Do you know why? Somebody guess?
Slow.
It was slow. Yes, indeed it was slow, but they had a more vital reason. Type checking. Yes, sort of. The real reason was that they couldn't run any of their programs, because once you translate the Fortran program into Algol, within the first few milliseconds of running it, it comes up with a subscript error. Now, of course, I said, well, that's a good thing, isn't it? Now you know, correct it. No, they said, I don't care about the subscript error. I just want it to run the same way that it does on a 7090. And so, I mean, quite reasonably, they weren't going to go through all the Fortran programs, which our rivals' computers could run perfectly well, just to remove little mistakes like subscript errors. And they never did. But now things have changed a bit. People are a little bit more worried about errors, and they are moving to languages like Java, in which subscript checking is standard. So everything so far seems fine. We've got our object orientation with careful type checking of all the pointers. So everything is all quite safe, and there's no overhead of testing every subscript for its correctness. And then I went and invented a null pointer. And the null pointer, if you use a null pointer, you either have to check every reference or you risk disaster. Most people, of course, like Fortran programmers, preferred to risk disaster, indeed to suffer disaster, rather than check all their subscripts. I didn't know that at the time, but my friend Edsger Dijkstra, who was also working with the team developing Algol 60, thought the null reference was a bad idea. And he gave a very, very subtle and very abstract reason for it. Yeah. He said, if you have a null reference, then every bachelor whom you represent in your object structure will seem to be married polygamously, or rather polyandrously, to the same person. Let's call her Nulla. I thought that was a rather nice criticism, but my real criticism is that it brings back again unnecessarily all the agony of having to choose whether to run your program fast without checking or run it slow with checking. Now, I did know that there was a solution to this problem. It was based on the idea of discrimination between objects belonging to a disjoint union class. An idea which I got from pure mathematics is that of a disjoint union, that is a union between two sets which have no members in common. So a language can quite reasonably have a facility for declaring a new class, not as the Cartesian product of attributes drawn from other classes, but rather as a disjoint union of various other classes. For example, if you had a class of vehicles, you might classify the vehicles as either buses or private cars, and separately declare different structures of attributes for each of those two classes. So a bus might have an attribute which indicated the maximum number of passengers, and a private car might have an attribute which gave you the capacity of the trunk or the boot, the luggage carrying capacity, as opposed to the passenger carrying capacity. And every time you accessed either of those components of the object, you would have to do it within a discrimination clause which tested. It looked at a vehicle. With a vehicle, it would say, when it is a bus, you can look at its number of passengers, and when it is a car, you can look at the capacity of the trunk or the boot. But you rapidly see that the size of the program, the source program, gets quite a bit larger by having to make all these discrimination clauses, and you're going to have to deal with both cases separately. Now, if we insisted on a discrimination clause, then we should make null not into a value of a pointer, but rather into a class which never had any objects in it, and which only had one pointer, which obviously didn't point to any object. So now, whenever you wanted to have a null pointer, you would declare your pointer to be either a pointer to the null class or a pointer to, shall we say, the vehicle class or the wife class. And that would give you a way of specifying whether you wanted this pointer to be able to take a null value or not, or whether you wanted it to remain definitely pointing to something, and you would never have to test. Do a few exercises using this particular notation. You see again, it's really quite cumbersome, and there are a lot of corner cases. What happens if you assign a new value to the pointer which you are currently analyzing and assuming to be a member of the bus class? So inside the code which processes the buses, you assign to the pointer itself a pointer to a car. Language design is a terrible job. You always have to think of these corner cases. Well, perhaps we could forbid that. Then there's an even worse problem with initialization. One of the things you want a high-level language to do for you is to protect you against uninitialized variables. And the standard way of doing that is to assign a fixed known value to every variable or attribute. And null is a very, well, it's really the only certain thing that you can assign as a value of an attribute to a recently created pointer or pointer attribute. And so if you want to get around, if you want to avoid using null, then you have to invent a whole sort of sub-language to use for initializing pointers that aren't allowed to be null. And this is all right as long as all your objects are in a tree structure, because you can then start with the leaves of the tree and build up in a hierarchical and well-ordered fashion the value of a little tree network to be the initial value of your new variable. But if you wanted to create a cyclic structure this way, there's no way of doing it. In normal programming, you would assign a null value to the pointer, and later on you would insert the cyclic pointer perhaps to somewhere else in the tree. Anyway, all those problems, in the end, I didn't want to deal with, and that led me to suggest that the null pointer was a possible value of every reference variable and a possible mistake on every use of that reference variable. And perhaps it was $1 billion mistake. Well, the world is gradually recovering from the mistake, I'm glad to say. And modern languages like C# or Spec Sharp, and I think even Java, are introducing the idea of reference declarations which are declared to be non-null, and reference parameters which are declared to be non-null, and compile time checking, which checks that such variables do not have, could not possibly have null values. And they have had to tackle all the problems of initialization and discrimination in a context which is now very much more complicated than I'd ever thought of. All the context of overloading and inheritance makes the concept of initialization very much more elaborate than I would ever have dreamt of. But that is what is happening. I think the movement must have been motivated by the fact that null references were an expensive mistake. And expensive, the figure of $1 billion is, no, I think we ought to put things in reasonable proportion. But perhaps I ought to say, I did feel I ought to take responsibility for this mistake. But I thought perhaps since it was unlikely that I'd ever be able to pay back $1 billion, I would keep rather quiet about it. So don't tell anybody, please. Yes, I put forward the view, which really derived from my very first experience of making the Algol implementation proof against octal dumps. It was octal dumps in those days, not hexadecimal. That a programming language designer should be responsible for the mistakes that are made by the programmers using the language. So, and that means that programming language design is really rather a serious engineering activity, not one that you should give to, shall we say, programmers with 9 months' experience of machine code programming, but one which requires a good scientific basis, a good understanding, a great deal of ingenuity and invention, a lot of control of detail, and a clear objective that the programs that are written by people using that language would be correct, would be proof against at least certain kinds of errors, and perhaps as easy as possible to get right. Anyway, not full of little traps and syntactic awkwardnesses that people are constantly bumping their toes against. This was the view that led me to the idea of using proof, using formal verification of programs as logical and mathematical models is a method of conducting research into the design of good programming languages. I wasn't too optimistic in 1969 about the likelihood that people out there would actually be using proofs to guarantee the correctness of their programs, at least not in the immediate future. In fact, not for the next 30 years was my prediction. But that by investigating the logical properties of your programming language and finding out how difficult it would be to prove correctness if you wanted to, you would get an objective measurement of how easy the language was to use correctly. So if the proof of program correctness requires a very large number of different proof rules, and if each proof rule has a lot of side conditions, in particular, if the validity of the local application of a rule to a small bit of program depends on properties which can only be established by a scan of the program as a whole, then you know that you've done a bad job as a language designer, and you do not have to get your customers to tell you that. Mind you, they don't, because it's actually very easy to persuade the customers of your language that everything that goes wrong is their fault and not yours. But I rejected that. I thought, no, language design is a serious scientific engineering activity, and we should begin to take responsibility for the mistakes that our users make in the use of our languages. That's beginning to happen again. The Java programming language and its successors have all used avoidance of error as one of the criteria that they use in the detailed design of new features of the language. And I have to give them, I'm delighted to give them a great deal of credit for that. Of course, it is only one of the criteria, and it's not, or at least it wasn't, at the time, the most important criterion. The most important criterion, of course, was compatibility with everything that has gone before. You can't throw away so many of the millions or millions of lines of code that have been written in other languages. So one has to, well, as in every engineering and every commercial product, you have to make concessions to the commercial and historical reality. You cannot pursue an ideal to its limit, but gradually ideas change, and programmers get more interested in correctness and demonstrable correctness, and production techniques and languages and checkers, analytical tools, test case generators and so on, that are going to help them to get their programs correct. The analogy that I draw is with agricultural pollution and with vehicle safety. When Ralph Nader first started publishing his articles and books on unsafe at any speed, what he was saying had no connection with the marketplace. The customers were just not asking for reliability or safety as one of the properties of their vehicles. But gradually, over 20, 30 years, customer feeling about unreliable vehicles has changed with the aid of lawmaking. There are legal constraints now which require basic standards of safety to be built into every vehicle sold. And so there is a possibility at least, that the marketplace and the commercial necessity will move in the direction of greater reliability of programs and of the languages in which they're expressed. You know what's driving this? A move towards more ideal programming languages?
Alan Kay?
It's not idealism, you know. Although I think for many professional engineers in the sense that I described in my opening lecture, they do have ideals and they do pursue them in preference to not pursuing them whenever the opportunity arises. No, the real commercial imperative, which requires greater attention paid to formal correctness of the programs, it's the virus. See, the virus, or the malware, the worm, or whatever it is you call it, it enters your computer and does dreadful things to it. It reaches parts of your program that normal execution never reaches. So it's no longer adequate to test your program against all the cases that are likely to arise. Because even if you succeed in testing against all the cases that are likely to arise, the virus will find a case that is not likely to arise. So it forces you to get the whole program correct, not just the parts that are going to be used by your customers. You've got to get the parts that will be used by viruses correct too. And that can't be done by testing. It has to be done by analysis. By analysis of the source code using type checking techniques, obviously, they are the simplest, but increasingly more and more sophisticated reasoning techniques are being applied to high volume code to check that it doesn't contain any of naughty things like null reference dereferencing. Well, if I'm responsible for $1 billion mistake, I think my reason for bringing it up is only to put even more blame elsewhere. The designers of C, well, one can definitely quantify, because the buffer overflow is a direct result of the get routine in C, which does not check the subscript bounds of the string that it is asked to input. That allowed the early viruses to get in by overwriting the return pointers in the code, and these early, very simple viruses taught the world how to write malware. Without this very simple entry point, it is quite possible that nobody would ever have thought to look for the more subtle things which are now being exploited every day by people who are now motivated and skilled, and whose profession it is, and indeed whose income it is, to write botware, another form of malware. So if it hadn't been for the get routine of C, we might have had no malware. Now, one virus, Code Red virus, some years ago now, I'm glad to say, was estimated to have cost the world economy $4 billion, because it really brought down all the networks in the world. And the interruption to business, ordinary banking and other businesses was estimated at that amount. And there was another one at a similar level. That, I think, is quite a lot more than the Millennium Bug, which was successfully averted at a cost a bit less than $4 billion, perhaps. So, right, that's my case. Any questions? Yes, sorry.
You shortly mentioned SpecSharp. What do you think about Singularity and SpecSharp, the approach from that?
I think they're both very strongly motivated by the same kind of ideals of making it easier to write correct programs. And they are they're research prototypes, of course, and they're therefore constructed to be.
Okay, I think that's it. We have to go back to our writing, which is what? Why is my OBS cannot go full screen for whatever reason? Okay. So this is because wine designing Argo Tony need a way to represent an absence of value, and null is an easy fix that turns out to be a big mistake. Programmer now has to handle null check. Saying a reference now could potentially be null. Not checking it result in crashes. Right? I think that's what I get from the talk. Um, the first C virus causes by buffer overrun, where it overrides the return value of a function so as to inject malware code into it. Right, the first C virus, eh? Buffer overrun. The modest one. What? What is this? Morris Worm source code. Okay. So that is good. So now we go up to the section where we talk about let's move it here. Okay, so where are we with the right? This is heading 1. Okay, let me turn on the music. Python path equal private testing algorithm. My original set something set that array over 32-bit and check. I think the constraint is that the constraint is that array value Very cute. There's Brian, here it comes, the author. maintain to frequency. Tracking number. It's basically ON. What? Okay. Okay, so eight rating, which user So what stream was that they recommend? What is this? Go back to my channel. Can I view my stream? How do I keep to my channel? Let's open in Chrome, I guess, because I have this extension. We'll take over. Group of hazard. So what stream was that? that this? Maybe this? How do I screenshot? Google Chrome screenshot. F12. Can we take a screenshot of the portion? Oh, let's go back to Firefox here. Okay, now. Do we have some pictures already? This one. Making sure that should always do is is take out all the debug. Okay. Merge interval. I would rather number of island. Working oriented. Generate parentheses. Alright, let's finish writing these two and then go eat. I'm hungry. Sort the interval to fix the first endpoint. Iterate and merge them. So and log in. If there is overlap. Alright, we go to house rubber. To simulate problem and cast them. The initial value set to -1 because there are cases when the house price is all 0. Okay, this is the code. So complexity is n to the n, right? Alright, so I think gotta go eat now. Good enough for now. We'll have to come back for this and then do the instant third. We do the instant third tomorrow maybe. All right. I think let me check if the draft has been saved. Okay, I think that's it for now. Probably play game at 1:30.